Hi, I'm Thomas. Welcome to math class. We're looking at differential calculus applications, and the concept we'll be discussing in this lesson is the concept of kinematics. And we'll start by considering three kinematics or movement concepts. The first is displacement. And displacement refers to my location in reference to a starting point, in reference to an origin. And our most basic function is the displacement function. The second concept is velocity. And velocity is similar to the concept of speed, but velocity has a direction. And when we refer to direction, we're talking about, generally we're doing some type of analysis with numbers referencing the coordinate plane. So working our way right on the x-axis will be positive, and left on the x-axis will be negative. Velocity is actually the derivative of displacement. And then our third concept is acceleration. And acceleration is change in velocity. The result of velocity is change in your position, or change in displacement. The result of acceleration is change in velocity. In other words, acceleration is the second derivative, or the derivative of velocity. And we're going to analyze these three concepts together. We can understand kinematics characteristics based on the output of our individual functions. So for the displacement function, at 0, a value of 0, our position is at origin. If we have a positive value in the displacement function, we're to the right of the origin. And if we have a negative output, we're to the left of the origin. Velocity has a similar interpretation based on 0, positive, negative outputs. If our value is 0, velocity of 0 means no movement. We are at rest. Positive velocity means movement right. And a negative velocity means movement left. And finally, let's look at acceleration. A 0 output for the acceleration function means velocity is either at a maximum, or at a minimum, or not changing, constant. So three possible interpretations of an acceleration function output of 0. Positive output, velocity is increasing. And a negative output, velocity is decreasing. So we can interpret the outputs of our three functions based on this analysis. Let's look at two additional terminology concepts, and then we'll move on to an example. First, speed. Speed is the velocity's absolute value, or the magnitude of velocity. Velocity can be positive or negative, whereas speed can only be a positive value. And distance is not the same as displacement. we might need to calculate distance, and we'll do addition based on the interpretation of our functions as well as some diagramming that we're going to do. But as an example, if I were to walk 1 mile from my house and then walk back a half mile, my total distance of walking would be 1.5 miles, whereas my displacement, the distance from my origin, having walked a mile and then returned a half mile, would only be 1/2 mile. So distance is not the same as displacement. We have a function for displacement. We'll use math and graph analysis to calculate distance. Now let's look at an example. We'll start with a displacement function, which is t to the power of 3 minus 3t plus 1. And for my velocity function, I want the derivative of the displacement function. The derivative of t to the power of 3 is 3t squared. The derivative of 3t is 3, and the derivative of 1 is 0. For my velocity function, I have 3t squared minus 3. And my acceleration function is the derivative of the velocity function. So for acceleration, I have the derivative of 3t squared is 6t, and the derivative of 3 is 0. So my acceleration function is 6t. I also want to create sign diagrams for my velocity and acceleration functions. So I'll simplify my velocity function to become 3 times t plus 1 times t minus 1. And the sign diagram, I have a critical point at the value of 1. My two solutions are -1 and 1. Recalling that t is time, I'm not going to have a -1 ever as an input, so I'm only going to consider the positive 1. Now I can create a sign diagram looking at this equation 3, and let's put in some test values of 1/2 and 2, values to the left and right of 1. When I put in the value of 1/2, I'll end up with 3 times a positive number, 1.5, times a negative number, -1/2. 3 times positive times negative will give me a negative value. And with an input of 2, 3 times positive will give me a positive value. So when time is greater than 1, the velocity function output is positive. When time is from 0 to 1, the output is negative. And I can do the same for my acceleration function. And with acceleration, I can see that any input after time 0 is going to result in a positive value. Now I'm going to analyze my initial conditions. What's the situation at time 0? And I can do this for displacement, and for velocity, and for acceleration. So the displacement of 0 is 0 cubed minus 3 times 0 plus 1 equals positive 1. For velocity, my input of 0 is 3 times 0 squared minus 3 equals -3. And the input of 0 into the acceleration function, 6 times 0 equals 0. And my interpretations are I am 1 unit right of origin in position. For velocity, I see I have a negative value, so I have leftward motion. And my speed, Let's go up to our original, let's go up to the displacement function and note that what we're calculating is centimeters, a value in centimeters. And let's also note that our time, our unit of time is seconds. So now coming back down to evaluate my velocity, my initial velocity of -3, I know that I'm moving leftward. I have a negative value. And speed, remember that speed is the absolute value of velocity. Speed is 3 centimeters per second. Units of distance are centimeters, units of time are seconds. And the output for the acceleration function is 0. I have 0 acceleration. No change at this point in my velocity. We'll break here and continue with our exercise in the next video.